In this video, we will first review the key aspects to consider before purchasing an electric compressor for automotive air conditioning, and then go through the essential steps to properly adapt it in a gasoline or diesel engine vehicle. Aspect number 1. Location and installation. A. The electric compressor can be mounted anywhere on the engine or vehicle, which is ideal for cars with limited space. B. However, keep in mind that the shorter the hose lengths between components, the lower the likelihood of vibrations and leaks. C. It does not need a mechanical connection with the vehicle's engine, no belt, which simplifies installation. However, it may require a higher capacity alternator to power the compressor correctly. Aspect number 2. Operation with the engine off and electrical requirements. The air conditioning will operate even with the engine off. However, if extended operation is desired, a higher capacity battery or an auxiliary battery may be necessary. It is necessary to check whether the current alternator can provide the required current for the electric compressor. Follow these steps. Check the alternator label. It usually indicates its capacity, e.g., 80 amps, 150 amps, etc. If there's no label or manufacturer data, you can perform a practical test using basic tools. Measure the alternator's output current. Use a DC clamp meter. Place the clamp around the positive cable going from the alternator to the battery. Ensure only that wire is inside the clamp for an accurate reading. Simulate a maximum load. Start the engine and rev between 1500 and 2500 RPM. That's where the alternator usually delivers peak output. Turn on all electrical devices, headlights, radio, wipers, air conditioning, etc. to simulate a high load. Check the current reading on the clamp meter. If the alternator is 90 amps, the reading should be close to 88 to 90 amps under full load. If the electric compressor is already installed, while the engine is running under load, measure the battery voltage with a multimeter. It should be between 13.8 and 14.5 volts. If it drops below 13 volts, it indicates the alternator is not supplying enough power. Aspect number 3. Fuel savings and efficiency. Electric compressors allow for greater fuel savings, as they operate independently of the engine and only run at higher speeds when more cooling is needed, adapting more precisely to the system's demand. If your main goal with the electric compressor is fuel savings, an inverter-type electric compressor is recommended. Although it may have a higher initial cost, it offers more precise and efficient cooling. If fuel savings are not a priority, you may choose a compressor with 2 or 3 fixed speeds. These are cheaper and easier to install but may save less fuel. Aspect number 4. System controls and safety. An automotive electric compressor requires the installation of high and low pressure switches, thermostats, and overload protection to ensure safe operation, just like a conventional compressor. Electric compressors come with an electronic controller, either built-in or separate, which regulates their operation, protects components, and improves efficiency. Make sure to use proper fuses and cables for electrical protection. Let's look at the steps to adapt it correctly. Step 1. Choose the compressor based on vehicle size. For a small vehicle, a capacity of 8,000 to 12,000 BTU per hour is recommended. These include cars like the Nissan March, Chevrolet Spark, Kia Picanto, or Toyota Aygo, small cabin vehicles that require less cooling. For a medium-sized vehicle, a capacity of 12,000 to 15,000 BTU/H is recommended. Examples include Toyota Yaris, Hyundai Accent, Volkswagen Virtus, Kia Rio, or Nissan Versa, vehicles with slightly larger cabins. For a larger midsize vehicle, 16,000 to 18,000 BTU/H is suggested. Examples: Toyota Corolla, Honda Civic, Ford EcoSport, Mazda CX-3. For vehicles with a larger interior volume, a capacity between 20,000 and 28,000 BTU/H is recommended. Examples: SUVs, vans, minivans, such as Chevrolet Tahoe, Ford Explorer, Hyundai Santa Fe, Dodge Caravan. These are designed to carry more passengers and have larger glass surfaces, increasing thermal load. Step 2. Choose the compressor type. If your priority is fuel savings, select an inverter electric compressor, which automatically adjusts its speed to deliver only the cooling needed. If fuel saving is not your goal, you can opt for a 2 or 3-speed fixed compressor. These are usually controlled via manual or automatic switches and are cheaper and easier to install. Step 3. Check the following before buying. A. Make sure the compressor size fits the available space in the engine or chassis. B. Evaluate the existing system. Decide whether to reuse components from the previous system, evaporator, condenser, piping, or install a new system from scratch. C. Inspect the current alternator. If the alternator lacks the required capacity, replace it with one of higher amperage. The ideal capacity depends on the compressor's current consumption. For example, a 40 amp compressor needs an 80 to 100 amp alternator to support other vehicle systems. Install proper wiring. D. Use high-capacity cables, a main fuse, a high-current relay, and ensure good connections to the control system. Install high and low pressure switches to prevent damage from too much or too little refrigerant. Step 4. Prepare the refrigeration system. Install the compressor securely and firmly. Evacuate the system completely before charging new refrigerant. Check for leaks by verifying if vacuum pressure holds consistently. Do a pre-charge of refrigerant before turning on the system, e.g., about 500 grams. Use the correct refrigerant, R134A or R1234YF, as specified by the compressor. Turn on the system and verify pressure and outlet temperature to confirm proper operation. Complete the refrigerant charge. With the system on, low side pressure with R134A should be around 35 psi, and with R1234YF around 39 psi.